Hello, everyone. I'm Josh. I'm the founder at Astria. I'm going to give another talk on shared sequencing after Ben's good talk. I'm going to be talking a lot more about network topology and a lot less about economics in this talk. So, the title of the talk is Shared Sequencers are Incentivized Relays. You could simplify it to sequencers or relays. I'm going to start off by giving some kind of like pre-context. So, like, why blockchains? Like, what are we doing with blockchains? Like, a general, like, why do we do the work to do this, and I'm going to argue that we use blockchains because we want settlement assurances. And then what are settlement assurances? This is one of my favorite quotes. It's from Nick Carter's It's the Settlement Assurances Stupid paper from 2019. And it says, settlement assurances refer to a system's ability to grant recipients confidence that an inbound transaction will not be reverted. And so I'll argue as like the premise to this talk that like the point of having blockchains as a general thing is because it gives us confidence that an inbound transaction will not be reversed. It gives us settlement assurances. Going to try to define a sequencer. I'm going to do a pretty simplistic kind of definition here. We're not going to try to stay out of the weeds a little bit. I'm going to argue a sequencer is just an entity making a commitment to an ordered list of transactions at a specific block height. And there's like valid reasons to disagree with that, but that's going to be what we're working off here. And so it's just this: you have some unordered transactions, and then you get an ordered block of these transactions, and that is what a sequencer does. What is a shared sequencer? Again, we're going to keep this simplistic. It is a sequencer used by multiple rollups. Like that, just we don't need to get more complicated than that. So this is like what we'd have as like a matrix, right? You can have centralized and independent sequencers. This is what we're mostly running today for kind of all the rollups present. We are looking in the kind of bottom right, where you have a decentralized and shared sequencer. That is, again, you have multiple sequencers as like actors in the system doing the job of sequencing for multiple rollups, which are using this logically single sequencer. What's a relay? So this definition actually comes from Stefan's original like MEVBoost post, and it is saying a relay is a party specialized in DOS protection and networking who validates and routes execution payloads to proposers. Why do blockchains have fees? So again, like why are we doing blockchain settlement assurances? Why do the blockchains have fees? I'll argue they have fees because of DOS protection, because submitting a transaction to the network imposes a cost, a burden on the entities which are running that network, and the way you pay for that burden, whether it is networking, compute, storage, memory, whatever, that is paid with fees, and that provides DOS protection. And so, kind of jumping back, right? What is a relay? A relay is a party specialized in DOS protection. The point of blockchains is settlement assurances, and why we have fees in these is for the DOS protection, right? I'm now going to go through. These might be out of date slides, but we'll just wing that there. The thing I'm going to go through here is I'm going to go give a high level kind of summary of different ecosystems network topologies with the kind of high level argument that these are all maybe not exactly the same, but very, very similar to each other. And that is a useful thing to kind of accept because that allows us to kind of coordinate a little bit more. So we'll start with Cosmos. Okay, these are definitely old slides. We'll try to work with that. Is it possible to refresh the slides? It's just like a Google sheet I sent. It should have been like update like an hour and a half ago, 2 hours ago now. Because otherwise it's gonna be somewhat. Because I just don't know where I'm gonna be going here. I sent it to Mel, and it's just like a Google sheet. So if you just like, I don't know how you guys write. It's like a hard Is this like running the like Google sheet of the full screen? If you just like hard refresh it, it might have them. Okay, we'll pause a sec because I can like wing it through that, but otherwise it's gonna be a lot easier if I have my actual slides. But yeah, at a high level, I'm gonna be going through multiple blockchain ecosystems to kind of argue that like these network topologies are similar. I'm gonna cover like Cosmos, I'm gonna cover Solana, Ethereum, and specifically Ethereum within like a PBS MEV supply chain, as well as I'm actually gonna go through like a non-blockchain network topology. So I'm gonna look at like Google's SRE book gives a lot of good information on kind of high level what you want network topologies to look like in large scale, high availability distributed systems. And there's a lot of similarities in the kind of boxes and arrows component diagrams between these systems. Daniel, you want to go? If we're going to do Q&A while we wait. I would argue like a Sybil attack probably has, like, it can be more nuanced in that, like, you can do something where, like, you are not DOSing the network and that, like, transactions are still going through the network. Other people are able to get their transaction through. You haven't, like, locked up the network, but some economic mechanism, whether it's defined at the chain level or it's defined at some smart contract or application that uses the network, that may have made an assumption. Ideally, we're not making these assumptions in blockchains, but if you look at, like, financial systems, like, writ large in, like, non-blockchain context, they make a lot of assumptions that are probably, like, vulnerable to, like, Sybil attacks. So I think you could have a Sybil attack that is not a DOS attack. I am not covering Sybil thing. My kind of naive assumption is that, like, blockchains somewhat intentionally do not kind of, like, uniquely, I guess they uniquely identify people in a pseudonymous fashion. But they are not, like, preventing, like, Sybil attacks generally, right? You can go into, like, WorldCoin and, like, various, like, trade-off spaces of, like, making sure you actually have, like, a unique identity. But I view it as, like, distinct. Again, I'm trying to focus mostly on, like, network topology, just, like, literally how transactions go through a network and what is, like, the goal of how the kind of, what is the flow of transactions through a network, and pointing out the similarities between, again, Cosmos, Solana, Ethereum rollups, even, like, just generalized distributed systems. I can also just try to wing it off the other slides. They're going to be like 50+% correct. Yeah, so I guess, like, the title of the talk, right, is the, like, a sequencer, a relay. Those are kind of similar things, right? They're maybe not exactly correct. Um, it's more kind of like the network architecture. It might not be like a literal one-to-one component being named, but the process by which, say, a user submits a transaction and, like, what that user wants to get out of that. Again, this settlement assurance. They want to be able to submit a transaction and ensure that transaction is included. Presumably, that transaction has some value to them, and thus they are willing to pay the fee to the network to include that transaction. I'm not going to be covering auction mechanisms and searchers and builders. I will be, like, papering over a lot of that. But it is the idea that, like, you know, they generally all have, like, RPC nodes or whatever, right? Like, you have some RPC node, and increasingly, if not, like, already, like, absolutely, the RPC node is a separate entity from, like, a validating node or, like, a block producing node. Like, those are separate entities, and that looks very similar to what we see in, like, distributed systems, where you have this multi-layered kind of topology of load balancers, to use just like a broad term, right? Of, an end user may interact with one node, and that node may itself not actually have, like, I'll say, like, the valuable state that the user is hoping to interact with, but it is the one responsible for getting the user's intent, transaction, whatever, to the data or the state change that they want to access. And that overall flow is relatively similar across a lot of different ecosystems. So specifically in this talk, I'm not necessarily, like, advocating for, like, a certain, like, things are this way and I think they should instead be this way. It is more kind of trying to construct useful mental models and say, like, hey, this is how I think a lot of these things are broadly similar. But I do think that we are seeing, again, across multiple ecosystems, increasing, like, specialization of work, right? Where we say, hey, actually, we don't just have, like, one node, and you have, whatever, like, N parties that all run that exact same node. And I'm not generally talking about, like, client diversity in that sense, but it is, this node is a full node, it is an RPC node, it is an archival node, it is a block producing node, and all of that is like, oh, I get clone geth and, like, run that on my box. And instead you're saying, well, these actual, like, network architectures look a bit different than that. And there is, like, value to having, this actor only does this job. So kind of jumping at, one of the key things is, like, and for my background, I spent a bit of time at, like, Google and, like, Google Cloud, and something that was, like, very obvious, like, Google has, like, an enormous amount of transactions, right? Like, we're in, like, millions of TPS. Are we just gonna go with the old slides? Okay. All right. So I will get to that part. I'm just gonna try to wing it through this. So again, we'll start with, like, shared sequencer, multiple rollups, bottom right. Relay, party specialized in DOS protection. We're talking about DOS protection. Not the same as Sybil resistance. We're just talking about DOS, just network throughput, right? But it validates and routes execution payloads. We'll cover that. That is not what I think is like, again, we're restricting the set of kind of like tasks that any given component does, and I would argue that that leads to like a better network topology. So what do blockchains have? Fees, again, DOS protection, Cosmos. What is Cosmos doing, right? I'll touch on, I guess, Cosmos before I go to Century Node architecture. So Cosmos at a very high level, I'm going to try to like talk through this. Generally, you have a split in a Cosmos SK application where you have Cosmos SK. This is the app state machine. So this is in Ethereum land. This would be like an execution client, right? This is where your valuable state is. This is where like Osmosis, why Osmosis is different than like Cosmos Hub is because they have different Cosmos apps, but both use Comet BFT as their consensus node. And in a Cosmos application, Comet BFT is the party responsible for doing peer-to-peer propagation of transactions, votes, blocks, right? In Cosmos, one of the things that is kind of like worth highlighting if you go into, also note I have a QR code at the end that should be up to date because I've updated the Notion. That is a bunch of references. There's like 45 reference links covering like deeper into each of these ecosystems. For Cosmos, there is a transaction lifecycle, and going into that, the key thing is that you do a stateful check on the app side before you propagate the transaction to the rest of the network. And I'm going to argue that that is an important thing that is shared broadly across all of these network topologies. And there's a good reason for that, and it does have some similarities to broader non-crypto, blockchain, whatever network topologies. They also have a Sentry node architecture, and this is actually something that was proposed by Jack Zampolin as far back as 2018 when it was like just the Cosmos Hub, and I don't even know if the Cosmos Hub was live then. And the thing that is relevant, I don't know if I have... Okay, I do have stateful check before. Okay, so actually, maybe these slides are up to date. This is a Sentry node architecture. Probably should put this on over. But the user submits to these sentries, and the key thing, again, is that these sentries are going to do their stateful checks prior to the actual transaction being broadcast to the network. The Sentry node architecture goes one more step, and that, again, we have this validator node here, and that validator node is going to be the one that is in the, like, peer-to-peer process here, right, of, like, voting. It is actually protected from the outside world. This is very similar, and I see kind of Cosmos explicitly do this more than, I'm assuming other like node operators like at scale, like if you look at like an Alchemy, if you look at like a Helios or whatever for like Alchemy and Ethereum and like Helios and Solana, they're probably doing this, but it is interesting to be like, well defined as far back as 2018 in Cosmos land. This is actually kind of providing a first pass, very like classic Web 2 load balancer that might do, I don't think it does it in like Sentry node, but it might do like TLS termination or something like that. If you go back to looking at like kind of Google network architecture when it was first leaked in 2009 as part of like the Chinese hacked them in like Operation Aurora or whatever, and you had this kind of smiley face diagram that was written on the kind of like leaked architectures, it was something that was like kind of like this. It made it past the first, I'll just call it like a firewall, as like a very broad path before it went into like the internal network. And so that internal network over the VPC, that is assumed to be trusted entities, and it is valuable to have a distinction between the outside world and a more inside kind of trusted thing. Going into kind of Solana and how it does it, key thing about Solana, no mempool, right? I'm not going to go into depth on things that like Jito and maybe others have on modifications to like Gulfstream that may give you kind of like a pending, pool or whatever like that. But we'll just assume it has no mempool. What that means is that your client, and when we say client here, I'm going to assume that's a user. These docs are also these are taken from like Helios write-ups. They have good stuff. Again, links in the end. You are a user, you send a transaction to RPC server. Because there's no mempool, there is not this kind of like peer-to-peer gossip of these nodes. There is actually a 2-day, I think it's 2, it might be like 3 days, look-ahead window, such that any RPC server, again, we have a separation between an RPC server and a validator here. That RPC is aware of who is going to be the actual block producer for a given kind of like time period, right, a given block, because you have like 4 slots, and this is known, again, 2 days ahead of time. So this RPC is actually going to directly forward a packet to the leader, and it is also going to send it to the next leader, and then the next leader. That is essentially a fallback mechanism. But again, the generalized architecture I want to get across here is that you have a user, and it is sending to an RPC server, and it is the RPC server's job to get the transaction to a place where it will be included in a block. But that RPC server itself is not technically a validator here, right? this is going a little more in depth into Solana's kind of like block propagation architecture. I am not, and technically it's like shred propagation. They don't broadcast whole blocks. They broadcast like erasure coded shreds of a block so that you can reconstruct it. But it is like a useful kind of like reference to understand that, again, you have this user submitting to an RPC, which submits incoming transactions to the validator network. We're really going the last slide. It is submitting to the validators, which it believes are the highest likelihood to be the actual block producer kind of soonest for that user, because the user wants kind of fast transaction production, right? And then it is the validator's job within the network to actually broadcast the block, in this case in Solana, the shred, to the rest of the nodes in the network to get consensus on it, and essentially like commit to this block, right? So that is not the job of the RPC node, it is the job of the validator, and those are distinct parties here. I think Solana is the one, due to kind of high bandwidth requirements to run a node. They used to recommend like a 1 gig connection, now they recommend a 10 gig connection. They very early ran into a need to split RPC nodes and validator nodes, and this is something we're increasingly seeing in Cosmos land, especially with like Berachain's testnet, where we've had a lot of kind of like DOS issues in the mempool in Cosmos, and a lot of the solutions they're looking at are structurally very similar to this split that we already see in Solana, where an RPC node is going to do a different set of work than a validating node. And again, in Solana, is because if you're a validator, you might need to use a significant amount of your bandwidth budget to propagate these shreds between other validators in the network that may leave you insufficient bandwidth to actually satisfy your kind of user demands of submitting transactions to you, because you just have only so much bandwidth, right? Okay, I am missing. I'm going to try to jump through and see if I have. I'm very confused at how my slides are ordered right now. But I'll come back to the Google one. MEV supply chain here. So I'm going to just get like Ethereum section. When we say MEV supply chain, I'm going to talk about like Ethereum here. This is if you go into like MEV-Boost docs, right? Like the GitHub on like the MEV-Boost repo. This is roughly going to look at, what do I have for other pictures? Okay, I'm going to use this picture. Okay, we'll use this picture. Fundamentally going right to left here, right? We have users, they submit to searchers, builders. That is kind of the same thing at this point in 2024. But fundamentally what these builders do, again, a user, and I guess we don't have like RPCs here, so like I don't think I have a pointer. Between users and searchers, you're going to have like an RPC. This RPC could be, I guess if we look at this one, look on the left, I'm gonna call like the left, whatever half of that, we'll call that like RPC providers. This is what, this is pulled from the Flashbots, I'm not remember the name of it, their order flow kind of thing. They have a good site for this. This is going to be where the source of actual transactions come into the network. And so this is a useful example because that is obviously a very diverse set of parties that are receiving transactions for like end users, right? And then they go into a mempool and then they go into builders. So this is everything here is like before it gets to a builder. These are like solvers, searchers, et cetera, right? So we jump to the builder. The builder essentially is going to be getting those RPC node kind of receipts, and it's going to pass those to a relay, right? And there's like, whatever, we have like 3 relays here. There's like 5, 6 in practice, right? The relay's job is to then broadcast to the proposer. So once again, we have this network topology that separates where a user is submitting their actual transaction, their desire to get them in the network, and then the actual mechanism by which those transactions or blocks get propagated within the network. So again, the thing where is like there is like an external world that users are working with, and there is an internal world that the validators, proposers, whatever are kind of working with. In a like MEV boosty like PBS architecture, the relays are the parties that are responsible for that. If we try to remember, I don't know, I'm not gonna like try to jump through the slides because the order seems weird. But if we try to remember what a relay is here, right? It is a party that is responsible, is specialized for DOS protection, that is responsible for essentially like sharing these blocks across the network, right? So again, it's like this centralized kind of entity here that is responsible for kind of having high throughput of the actual kind of blocks to propagate through the network. Roll up. Let's see what we have there. Okay, so this is from Arbitrum's docs, and this is a roll-up thing. Roll-ups are actually like a relatively simplistic model where we're going to assume the L1 chain. You just assume you have like MEV, PBS, like whatever thing. Okay, 5 minutes. Oh, do I go faster, I guess? The sequencer is going to be like a single party, right? And so when I argue that sequencers are relays, right, Similar thing, we're just essentially centralizing the work into the sequencer. People remember from, I think it was actually last year at East Denver, was when you had the Arbitrum snafu, whatever, right? They were getting DOSed really hard. They talked about like nonces and like proof of work and whatever, and that was because the sequencer here is the party that is responsible for receiving essentially all of the inbound kind of transaction demand from end users, right? You had like one entity, and that entity was owned by like off-chain labs, right? So if we look back to here, right, everything on basically this slide, all of that stuff going to one party, right? And that led to problems, right? Essentially, it was like crashing the node. It had a lot of like connections open, right? And so that is like a problem. Again, I'm not going to go too far. I have like 5 minutes left, and I don't know where my slides are, but that sequencer is essentially trying to do the work of like many other parties across many other ecosystems. That led, maybe unsurprisingly, to like failures at kind of high throughput. Okay, I'm gonna go back to where the hell is it? Okay, this is actually what I wanted to kind of argue as like the end point. Right? This is not a blockchain at all. This is just like from Google's SRE book on how to run production systems at scale at high throughput. And we have a relatively simple like 5-step thing. What I want kind of people to pick out is like, look at that diagram and look at how it's kind of similar to a lot of the other ones, right? So step one, you have a user. Where is that user going to submit their transaction, their request, right? In Google land, this is like, I call it a search query, right? It's going to go to the GFE. The GFE is just a reverse proxy. In blockchain land, that's, I call it an RPC node or whatever. What is that RPC node going to do, right? It's going to terminate TCP. I am going to argue in very, very broad strokes that termination of TCP, similar like the Sentry pattern, similar to like Cosmos doing like pre-checking of kind of like stateful transactions before broadcasting to the mempool, that is a similar thing. It is responsible for receiving external user requests and doing a very minimal amount of work before forwarding it on. Internal to Google, there is not just one GFE. There is, when I was there like a couple years ago, there were 3 layers of this, where basically these things were getting such high throughput. You basically have a box, and it's a box with 4 terabytes of RAM and a large amount of bandwidth, and people hit it, and its only job is to then forward it to someone else. It does nothing else. All it does is it receives it and knows where to send it to somewhere else, because at some scale, you have to minimize the amount of work it can do, because even with a 4 terabyte RAM buffer, and with like, you know, north of 100 of these kind of globally distributed, you just had to kind of throw it to someone else. Are we at 2 minutes, or are we more than 2 minutes? Okay. And then that GFE, it's going to send to the application front end. We could argue that's like a validator or something like that, right? The architecture doesn't hold kind of completely, but the other thing I want to note is that for the GFE to send to this application front end even, it goes and talks to this load balancer, right? It's GSLB, like a Google, I don't know what the S is, but like Google load balancer, right? It needs to know where to find the person that it is next sending something to. If you look, all the boxes except for the user are talking to this like load balancer. Again, looking at the kind of relay picture, I don't think I have that slide in there now. You see a lot of interconnection where a builder is talking to a relay is talking to a proposer, and the relay is also the entity that is sending the proposed block to the rest of the network. Very similar to this GSLB. There's a single thing that is responsible for kind of mediating communication across the broader network, right? Step 4, you application front end, get to the BNS. You know, we don't really need to think about like, the general thing I want to cover here, right, is like you have a GFE. That is first point where a user goes to. It needs to find where things are, so it has some centralized air traffic controller or whatever, right? That is similar to a relay, and then it propagates through the stack. We're gonna see where. Okay, Optimus relay is one thing I want to talk about. I'm not gonna get to like any like Astria things given like time here in order. We said that a relay was a party specialized in DOS protection and networking who validates and routes execution payloads. In practice, we have moved to optimistic relays for at least, I don't know, call it 35% of the network. They don't do the validation anymore. You just trust them. And that is, again, because we have to, it is this like air traffic controller. It is pinged by everything. It is important to the throughput and the liveness of the whole network. And thus, it cannot afford to do the additional work of actually validating that. So that is something that gets pushed to potentially like RPC nodes or searchers, builders, or, you know, look at the whole order flow thing. They have to do the checking that something is valid before it actually propagates internally to this network, to the relay, because the relay can't afford to do that. And so you have to pass that duty on to someone earlier in the stack before it gets to this part of the network. Again, going back to like, you know, settlement assurances, relevant thing here, right, is that an inbound transaction will not be reversed. When you say reversed, I'm going to assume that means it has first landed in state is actually update your bounce. That means settlement requires execution. So again, if we have taken the execution out of the relay, we have to put the execution somewhere else, right? So we can't just do unordered transaction to an order block. We actually have to have an executed block, which has a state DB and a resultant state root, right? going really quickly into Astria. So again, shared sequencer, right? This is high level what I think. The relevant bit is look at the left. We assume users are creating roll-up transactions. When they create that roll-up transaction, we are assuming they are actually communicating with a roll-up RPC. Again, similar to this order flow auction searcher builder mechanism, the shared sequencer is similar to an optimistic relay in that it is ignorant of what the given state machine of a roll-up is. It assumes that prior to a transaction being given to the shared sequencer network, it has already been validated via the state machine rules of any given rollup that is using it, and then it is forwarded into the network. And again, this is a separation of concerns. The shared sequencer doesn't care what you're doing on your rollup. Its job is to act very similarly to a relay. That's why I was talking shared sequencers are incentivized relays, right? The shared sequencer network is an incentivized network. It has like a token that will have to have fees, that is DOS protection for multiple entities, but its job is to ensure that multiple parties, multiple rollups, and users of those rollups are able to get their block propagated through the network, but it assumes that that means that the execution, whether that is done through order flow auction, searcher, builder, whatever, right, is done prior to it being submitted to the shared sequence. That's relevant, and that produces one block. It colors different rollups, right? Read the DA layer, not relevant for this. And then the rollup blocks are actually pulled out, and the state root has happened on like the read path. So that is the relevant bit there. This is a component level diagram. I'm not gonna do that. So what do we all share? That is an old slide. Oh, okay. Okay, all right, this is the final slide. So final summary, what are we doing in these networks? That is not the picture I wanted here, but okay. How much of this is correct? All right, we'll do 1, 2, 3, whatever, and there's 4. So user sends a transaction to an RPC node, right? The RPC does a stateful check on the transaction. The analogy in like a Web 2 world would be this is like terminating TLS or something like that. A very minimal amount of work to validate this packet is not like completely worthless before forwarding the network. The RPC, I'm gonna say it just gets the transaction to the block producer. How it does that is fundamentally like an implementation detail, but that's its job. This slide is not updated, that's funny. But then its job after that, right, is that the block producer's job is to get this block to the rest of the network. Going back to like a relay point, it actually again goes backwards where it says, hey, I got this block, I produced it, I'm gonna hand it the relay. The relay's job to propagate it across the whole network. But that is generally shared across like all of these systems, right? Cosmos, Solana, Ethereum, and PBS. We see sequencers like a centralizing vector that try to do all these things, and we see the resultant problems of them when we see very high throughput. Shared sequencer, relay, whatever. DOS protection costs money. That's like the other thing. Where why do we have problems with like the relays being incentivized? Because it costs a lot of money to run these. We put a lot of work on them because they are the central point that is kind of responsible for propagating all these blocks. I have heard numbers range from $100,000 a year to $500,000 a year. Sounds like a large range, but it's expensive, right? Here are references. This is a useful QR code if you're actually curious about digging into this. There should be a Notion doc. I'm hoping that is up to date. If someone could like look at that, let me know that actually like links. There should be a lot of like relatively categorized links on. Okay, so that is that. I know I'm over time here. Sorry for the confusion on slides. Yeah. Yeah, so again, I would argue that like having a single point, right? So like a centralized sequencer trying to do all of these roles is probably like pretty far on like, you know, I'm not gonna say it's like the worst, but it's pretty far on like the bad side of like ways to do that. You have fallbacks to like an L1 inclusion, but you know, we would assume that like, you know, if the like optimism arbitrum, whatever sequencer was down for like whatever, call it like 5 days or whatever, we would assume that people are going to generally view that as like a problem and not just fall back to L1. To give some like insight into kind of like different, I would say like actual like quantitative metrics, I would look at like mevboost.pix, I think, and one of the links in there, it might be the optimistic relay one. It's going to show that among the different actors here, so searchers, builders, and relays, they have different percentages of the censorship that they do, right? And so from a quantitative perspective, we are able to kind of see in the kind of PBS landscape who is actually censoring more. And I guess like without going into like a theoretical what is the optimal design, you can just kind of look at that and say like, all right, we should probably try to incentivize the system such that the actors that are less likely to censor are going to do it more. You get into kind of questions around like economics. I think we don't even see things being that problematic right now because I think most of the censorship is basically like people are like tornado cash dusted or whatever, right? But I think this will be a much more relevant question when we see things like, you know, Aztec has something that is like wholly private and like a distinct network, as well as things like Penumbra. I think Penumbra is going to be a very interesting use case because it is wholly private, right? But it has like IBC connections. So there's going to be a question whether we see, and I didn't go into that as far as timing, whether we see censorship at a relay level from doing like IBC broadcasting because someone feels like they're in a jurisdiction where they're not even allowed to pick up a transaction and drop it on something like Penumbra, because the view would be that, oh, Penumbra is only used for criminal activity or whatever, and therefore even allowing someone to onboard there. Similar to Aztec, we might see things in like an L1 bridge contract where we actually see censorship to, oh, I'm not going to, you know, whether it's going to create a bundle, whether it's going to create a block, whether it's relaying a block, even at the L1, separate from the L2, which has its own sequencer. So I don't have like an ideological or like a theory. Yeah, I mean, it's from like a, you know, however you want to define like censorship as saying like the ability to include a transaction that is valid that pays some fee within some time t or whatever. We're actually not doing that badly, even with relatively centralized things. And that if we look at like relays, there's like 6 of them, and builders, there's like, you know, a lot, but it's really like, I don't know, like 4 or whatever. I don't remember the number of the time. But even with that, right, we're having like whatever, like 27% of them are like non-censoring, and so it's just like you can get a transaction in, right? You might have to wait like whatever, like 36 seconds or something. So my view is like the low hanging fruit, even just like the making it workable, right? Like a practical thing, you can get it done with like 4 people, right? You just don't need that many people, right? It's like basically like, I don't know, like don't have your only node in like a Western European or American NATO aligned like entity wherein they're concerned with things. Just like be like, there are 2 nodes and one is there and one is like, I don't know, put it in like Hungary or whatever, right? Like someone that's like not in, why did I say Hungary is NATO? So, yeah, but like, you know, they don't like, you know, like that's going to be, you know, they'll push back a little more, maybe put it in like, I don't know, pick another country, right? You don't want to touch, you don't want to touch like what, like 3 countries or whatever, right? You know, but it's not that hard to resolve in like a practical sense. You need like 1 node somewhere, right? And you need the economic mechanism such that there can be a long tail. If you want to look in like a theoretical thing, inclusion lists and like various things in that mechanism. But again, it's just like you need some mechanism within some time to just have like a node running in whatever, like a jurisdiction that's fine. And then like, you know, because again, if we take this like logical extreme, it's like we're not doing anything about BGP, right? Like, okay, you know, they're like, I'm going to censor your like tornado cash transaction at the BGP layer. Like, no one in this room has a resolution to that. Okay, thank you guys.